All right, everyone, welcome to OffensiveCon. Welcome to my keynote, which I've decided to call Rules to Hack By. And my name is Mark Dowd. I'm on Twitter. So any comments or follow-up, you can DM me there. So a little bit about this keynote and why I've decided to do it. So I've done vulnerability research for pretty much my whole career. I started as a hobby and then went into it professionally, releasing advisories and doing presentations and so on. And then wrote a book called Art of Software Security Assessment on the subject before finally founding my own offensive research company, Azimuth, which I've been doing for the last 12 years. And throughout my career, the thing that people most often have asked me is, how do you actually find bugs in like major software? You know, like we know what an integer overflow is, we know what a use after free is, etc. How do you actually apply that to doing real vulnerability research? And it's an interesting question because this process doesn't actually get discussed very often. Usually you see presentations where they talk about a really cool vulnerability, a really cool exploit, or perhaps a tool related to those. And it doesn't really talk about the process of what it's like to be a vulnerability researcher and what's actually involved in it. You can learn the mechanics of a magic trick, but it gives you very limited insight into how to be a magician. And so when I wrote Art of Software Security Assessment, I was trying to share some of this knowledge. And at the time, I was focused more on the technical aspects of it because there wasn't really a compendium of information like tying together, different bug classes and things like that. So that's mostly what that book was. And even though it did talk about methodology and things like that, it was kind of limited. So today, really, what I want to talk about is some of the rules that I've sort of developed over my career of how I do vulnerability research. And obviously every researcher does it a little bit differently. They have different procedures and techniques and stuff. So, your style and mileage may vary. But I know that speaking with other people in the industry and within Azimuth that there's common elements that most successful vulnerability researchers sort of know, but it kind of gets left unsaid. And so that's what I'm hoping to talk about today. It's a pretty high-level presentation as it's a keynote, so I'm not really going to go into too much technical details. And so I'm kind of hoping that there's something in this for everyone here. First of all, for non-practitioners, they'll get an idea of what it's like being a vulnerability researcher and what kind of things you deal with. For juniors in the field, hopefully there'll be some actionable advice that they can take away from here. And then for senior researchers, I think it'll be interesting to sort of compare and contrast some of the techniques here. Maybe you get some ideas, or better yet, maybe you have some ideas that I haven't thought of and can come and tell me later. Because, I mean, why should you guys get all the benefit? And so, basically, I'm hoping this will encourage, sharing of those other experiences from other researchers and, start to demystify, this practice, because a lot of people seem to think that you either are a vulnerability researcher or you're not capable of it, and I don't really think that that's true. Before I go on to talk about the actual auditing stuff, I want to talk a little bit about like the temperament of vulnerability research and the mindset, because I think this is one of the key differentiators between what makes someone good at vulnerability research and what makes them like burned out and horribly depressed. So there's a couple of things I want to go over here. First of all, if we think about temperament, it's no surprise that vulnerability researchers have a curious nature and are very detail-oriented. But I think one of the more important things to take into account is when you're doing vulnerability research, you're constantly digging into code that is evidence to you that you don't really understand a lot of the technology that you think you do, or you don't understand it quite as well as you think you do. There are a few jobs, as I put up there, where it is more apparent that your understanding of technology is quite wrong. And so being able to take on that new information in a positive mindset is I think, what makes people successful. And even more so, vulnerability research is dealing with constant failure. I know this sounds super bleak, but it's actually a pretty fun job. And if you can deal with failure constructively, I think that is basically one of the most key skills in being a vulnerability researcher. People that don't do this naturally, I think that by becoming aware of this and sort of developing strategies for themselves can help improve their vulnerability research in addition to just having their technical knowledge. So talking about failure, first of all, dealing with failure is a very constant part of vulnerability research. I once attended a Black Hat conference where someone came up to me at the time I was releasing a lot of vulnerabilities and doing presentations, and they said something along the lines to me, like sort of trying to give a compliment of, you can put any code base in front of this guy, he'll find a vulnerability in 20 minutes. And I was struck at how wrong that was, because I fail all the time. In fact, most of the time when I'm doing vulnerability research, I'm failing at it. But of course, this guy just sees the advisories and presentations and thinks everything I'm doing is turning to gold or whatever. I don't know how other people deal with this failure, but I know some of the strategies that I've used. The first main one that I really would say is that I always have two projects going on when I do vulnerability research. They can be either different components of the same code that I'm looking at, or the second one is completely unrelated to the first. And I try and learn to recognize when I've hit a wall and become unproductive. So at a certain point of a vulnerability research project, all my ideas will be exhausted. I have nothing new that I can think of, or perhaps I'm having a difficulty understanding like a key component. And basically, when you get into this mode, you slip into being quite unproductive, and it can be quite depressing, and your concentration starts lagging and so on. So recognizing when this happens and then switching to a secondary project kind of perks you up, because you're able to put that thing away. The frustration dissipates because you can make progress on a different project. And not only that, I think that by putting something away for like a day or a week or whatever, it percolates in the back of your mind. And some of the best ideas you have with vulnerability research come from when you're not actively doing something, but when you've got all the facts and it's just sort of happening in the back of your mind. Even better is if your second project is a development project, because unlike vulnerability research, you can do sort of an achievable and measurable task. You can go and do that feature that you've been meaning to do, and it's something that is concrete and you can measure it and sort of get a sense of achievement and get your motivation back before switching back to the other thing. Now, even doing this strategy, of course, perseverance is really important, and going back to things and trying to overcome, trying to look at code until you find vulnerabilities. But at some point, you switch away from a project and go back to it two or three times, and you keep hitting the same wall. You're not getting any new ideas. It's not really working for you. And this can be a massive drag on motivation and confidence. And it's really hard to put away, because there's a sunk cost fallacy where you're like, I've spent all of this time learning about this code base. I know everything about it, and I can't put it away till I find something cool. But what you have to realize is that even if you put it away, the project is not a waste of time. The intent is to return to it in future. What you've done is pay the startup cost of understanding that entire code base. And when you come back to it in like 6 months or a year's time, there'll be some fresh features and stuff like that. Perhaps there'll be advancements in offensive security that you hadn't thought of at the time when you looked at it. Your own skills have become more sophisticated, and you can basically hit the ground running because you already understand fairly intimately that code base. In terms of motivation, I don't really know how to tell people how to remain engaged in looking at code. Essentially, as I said in the first slide, most vulnerability researchers are curious. I would say that in in addition to looking for just vulnerabilities, I don't really look for vulnerabilities quite a lot of the time. I'm just trying to understand how technology works. And the curiosity about how that technology works can make code an awful lot more interesting to look at, especially when you're finding out how a completely new technology works, or perhaps it's something you thought you understood, but you're finding out new details about it that you only really get by really studying a code base that you weren't familiar with before. So the more you're interested in the technology, I think the less monotonous code review is. And also, I kind of like looking at the algorithms people use to solve the same kind of problems. And sometimes they do a cool programming trick, and I just think, oh, I'm going to steal that for the next thing I write. So that's kind of cool as well. I can't really talk about motivational problems in vulnerability research without talking about bug patching, because it can be pretty brutal. Bugs being patched is a really frustrating experience, but if a security patch comes out for something that you already found, it's also kind of evidence that you're on the right track. You understand what vulnerabilities look like in the context of this code base, and it's just been validated for you. So that can be some motivation to keep going. But it can be frustrating. I had an experience early on in Azimuth where I'd found these 2 vulnerabilities in Chrome, so I was pretty happy. And they basically got patched 2 days later, which caused me to go on what we call at Azimuth a rage audit, where you basically try and avenge your dead bugs by looking at the code obstinately. And I was able to find another vulnerability and write an exploit for it, so pretty happy with that. But then a week later they patched that. And so that's like super frustrating and can happen. I guess you can take up boxing or something. I was able to turn this into a positive because I looked at the advisories coming out from Google and noticed that the same guy had submitted all of those bugs to Google, and so I just hired that guy. And that took care of that problem. So a tip is start a vulnerability research company and then just hire everyone if you can. Patches are also a double-edged sword, really, because as well as things being patched in your face, they're actually really good documentation for when you're familiarizing yourself with the code base. They're really good because they tell you, like, you can go, when you go through patches, they can give you inspiration for ideas that you didn't yet have, or variants or patterns that you hadn't yet thought of. And they can help you understand what bugs look like in the context of this particular code base, because they will show you, where a bug is, but they won't really, but it might not be immediately obvious what it is or why it's a security problem. And so going and working that out can be really helpful for your understanding. Confidence is another thing. Vulnerability research is a pretty daunting field to enter. You see cool stuff coming out all the time, and it seems like totally impossible. And even for experienced researchers, if you're experienced in one area of technology and you jump into a totally new one, like you go from kernel hacking into browser hacking or something like that, it can be very daunting. But I'm going to tell you that some security researchers, I won't speak for all of you, but some security researchers you respect have had the same self-doubt coming in that juniors have, and recurrences from time to time as they're switching technology. When I was entering vulnerability research, I was like very unconfident. Even before I got the code base, I was like, it seems a bit arrogant for someone like me who had little experience or knowledge to be able to download this code base written by some internet god and deployed on millions of machines and expect to find fault there. But I kind of did it anyway because I'm like, no one knows I'm looking at it. I'll just be arrogant and secret. And I would be overwhelmed by the complexity of it and think like, what the hell is this code doing? Do I even know C? It makes you question yourself, or assembly or whatever. But as you look at it, I would just start and try and understand the smallest bits that required the least amount of context. And once I understood this little bit, I would then move on to like another component that was perhaps a consumer of that, and so on. And basically you broaden your context, and then after a while you start to realize like, oh, actually I kind of understand this whole component. And that's where bugs kind of come from. That understanding, then you start seeing like, oh, wait a minute, they can't clean up this over here because they've already done it over here, kind of thing. And so just starting out small and then moving bigger can be really helpful for confidence. Another thing, as a junior, you can look at vulnerability research and sort of be like, something comes out and you're like, that's impossible. I can't see how anyone could do this vulnerability research or this cool exploit. But one of the things I've told other juniors in the past is a lot of the product that you're seeing is the culmination of hundreds or thousands of hours of practice that person has put in to get their sophistication of understanding a technology and understanding the principles of exploitation and so forth up to a level where they were able to do that work. And so, of course, when you're at the beginning, you can't do that work. However, one thing that's useful is even vulnerability researchers, really premier ones, if you look back at some of the stuff that they've released in the past, like a year ago, 3 years ago, or 5 years ago or something, you'll see basically that they've gone through a path of increasing sophistication themselves. And so you might not understand how they did the thing they did today, but you can look at something they did like 5 years ago and see, okay, I can see a path to get to that. And from there, you can see that there's a roadmap for you, if you're prepared to put in the same amount of work as they have, to be able to get to the level that they're at. So it's really about having a growth mindset, I guess, about rather than looking at something and saying, I can't do that, saying like, I can't do that yet. The last thing I sort of wanted to talk about here was sort of bias and assumptions. I think that when you're looking through code, a lot of vulnerabilities you find are the result of assumptions that a programmer makes, and that's pretty straightforward. But I think actually the security research community has a number of biases and assumptions that you can fall prey to from time to time, and they have an opportunity cost of you missing out on finding some potentially cool vulnerabilities. The first one that I encountered early in my career was everyone has looked at this already. At the time, there was this big open source and closed source debate in which one's more secure going on, and the mantra of the open source people was many eyes make all bugs shallow. Therefore, open source code is, if it has bugs in it, it's not going to have bugs for very long. That sort of turned out to be wrong. But what I realized for some of the most major applications, in particular the most major applications, I started to realize that not many people were looking at them at all, because everyone thought that everyone else was looking at them. And while there was, I'm sure plenty of people were doing cursory examinations of like, oh, I'll just check if there's integer overflows in this, actually putting in the time to fully understand the complexity of the code and find some of the more subtle bugs was something that I think happened rarely, if ever. And so once I discovered this was my whole early career. I would just look at all these major applications, and everyone was constantly surprised that I was able to find these bugs in code that no one else was looking at, as far as I could tell. And another bias that I think some people fall for from time to time, and I've fallen for this one a lot, is even if I found something, it will be unexploitable. So there was this period of time where the entire research community basically went from finding server-side bugs to client-side bugs, and it was around the introduction of ASLR and DEP and some of those related mitigations. That wasn't the only reason. People were starting to realize how rich the client-side attack surface was and things like that, compared to the server-side surface, which was in general a lot smaller. But also there was a kind of perception of like, even if we found something, it's not going to be, it's going to be really difficult to make a reliable exploit. It's probably not going to be possible. And there really has been a focus for a long time on client-side stuff in the research community until several years ago. I think it was around, I would say it's around when Eternal Blue came out. I mean, when you think about it, how many times in the history of ASLR has there been the case where it's like everything is randomized in memory and you can't tell where everything is, except for this one object, which is always in the same place and is really useful for exploitation. And so Eternal Blue used a mechanism like that, and then people started going on to look at other server-side, or I should say interactionless vulnerabilities, iMessage for iOS, some of the other messenger applications, and recently, Windows DNS and Windows HTTP and things like that. And it turned out that, like, in a lot of these cases, some of the cases the mitigations would be useful, but a lot of the time they could be worked around in a reliable way. And so the next one is this attack surface has been mined to death. There's nothing else there. So when I started looking at browser vulnerabilities, I found this bug in like array.join or something like that. And my mind is constantly blown how every year like 2 or 3 new vulnerabilities come out in these same 2 functions. Like every major browser has had it, and basically the reason they keep coming out really is because you have a vulnerability, pretty straightforward, it gets found, it gets fixed, and then a more subtle variation of that gets introduced or exists, and then that gets found and fixed. Then a more subtle version again, perhaps involving the JIT engine, gets found and fixed. And also all the time they keep rewriting these functions and then reintroducing the bugs that they fixed like 2 years ago. So even though you've seen a lot of vulnerabilities in a particular thing and it's tempting to think that there's nothing else there, these code bases move very fast, and it can be worth having a look. The last thing I want to mention here is a lot of the times you can have this subconscious kind of bias about how a protocol or how a well-formed file for a particular thing you're looking at works. And it's amazing how much it can influence the limiting of your imagination sometimes. And developers do this all the time because that's where you sort of find bugs. They write something that implements a protocol or whatever, but it allows you to do more really than what the protocol specification says. But one thing I've found useful in the past is I purposely don't read any documentation about the technology I'm looking at until I'm halfway through. And I've found that the times when I've done that, there's a lot of times where the experiments I've done from reading the code, when I go and read the protocol documentation, suggest that that's not a thing at all that can ever happen. And it's kind of surprising that a program can do it. And it hadn't occurred to me because I was too stupid to know how to use the protocol properly. And so I now specifically do that to avoid the bias, and then go and read it halfway through to resolve the ambiguities that I didn't quite understand when I was reading the code. So that's really all I want to talk about for the the mental aspect. There was a lot more stuff that I wanted to pack into this this presentation, but it was going to go for like 4 hours. So this is very brief, and depending on how it goes, I'll follow up with a lot more of the material that I cut out. But I'm going to move on to the major auditing processes now. Again, a couple of major points, but not nearly enough time to fit everything in. Okay, so this is something I talked about a little bit in the previous sections, attempting to understand the code. This seems like a silly thing to say, really, because this is obviously the object of vulnerability research. But over my career, I've noticed that a lot of people try to short-circuit, actually put quite a lot of effort into short-circuiting this process, and rely on tools such as fuzzers, static analysis tools, and perhaps taxonomies on bug classes and things like that. These things are very useful and can greatly assist vulnerability research, but they are not the entirety of the process. Tools can fail to find vulnerabilities where you will succeed, and some of them, and even though tools have got quite sophisticated and can find a lot of the low-hanging fruit and perhaps the medium-hanging fruit, they sometimes miss even those. Tavis Ormandy from Project Zero released a vulnerability late last year in the SSL library NSS maintained by Mozilla, and it was just a straightforward heap overflow. And he has an interesting blog about it where he talks about they fuzz it all the time. They had static analysis tools running on it, and he sort of talks about the fault in their testing process. that you can go and read about on his blog, and where he thought the testing fell short and why he found it where they failed. But that sort of goes to the point of tools only. Tools, while effective, cannot do the entire job. And perhaps more importantly, a lot of today's vulnerabilities are quite complex and require sort of an in-depth understanding of the code base you're looking at. Usually vulnerabilities, I find these days, come about because you notice a small idiosyncrasy or a quirky API that has an easy to misuse interface perhaps, and sort of chaining ideas together until you work into something that has a security consequence. Your advantage as a security researcher is you have the ability to understand this context and be able to consider things in a creative manner that perhaps a tool can't. For example, Natalie Silvanovic last year released a Signal vulnerability, and obviously because of Signals, the consequences of Signal being used by security people and all over the world and so on, probably a lot of people have spent time looking at that code and running tools on it and so forth. She found a bug that required understanding the context of the state machine. She spent some time learning about WebRTC and SDP specifically, but by understanding that if you've got this state machine and you can reach this state which involves turning a microphone or camera on without ever going through this state of initiating a call, then that constitutes a security problem in this particular context. And it turned out the state machine is more complicated than you might imagine, and so she was able to find a situation where you could indeed do that. Secondly, every mitigation bypass that you see is also kind of a context-specific vulnerability. Finding a bypass in a mitigation is just vulnerability hunting, except instead of looking for perhaps a traditional memory corruption bug or whatever, most of the time you're looking for a way to undermine a specific integrity validation algorithm. So, if you're looking at PAC, for example, you might be looking for ways to forge pointers or for a way to modify a pointer in a way that PAC doesn't detect it or something like that. Finding vulnerabilities of that nature requires you to understand the context of what PAC's trying to achieve, and then basically, what constitutes a problem in it and getting around that. So going back to the inconsistencies thing, Ian Beer also, I didn't mean all these examples to be from Google. I should have checked this more carefully. But Ian Beer did a good use after free that you can go and read up about as well recently in the iOS kernel. And this also kind of displays how having a really good working knowledge of what you're looking at and building one little step on top of the other can result in an interesting vulnerability. Without going into too much of the details, basically he identified an API that he thought was quite quirky. In simple terms, it was a function designed to take a port object and add a reference count to it. And he noticed that in one particular case, it won't actually be able to reference count it, and it will leave it as it was. The second thing he then found out is that function signals when it's unable to add a reference count, but there's one case where the function gets called where they never actually check that. And the reason they never actually check it in that particular case is because it's basically impossible for it for the port to be in the particular state where it won't reference count when it gets called there. But then he was able to apply his knowledge and go, well, is it really impossible? It's nearly impossible. And basically, by having knowledge of how some of mark messaging and the port subsystem worked in iOS, he was able to construct a race condition essentially where he could cause the port to be in the supposedly impossible state and trigger the vulnerability that results in a use after free. So it's kind of, so a lot of vulnerabilities are like that, where it's not just a straight up integer overflow or something. It involves having several pieces of context to understand what you're looking at and what a vulnerability might look like. The other thing about reading code, of course, is exploitation is really useful for exploitation. Most generic techniques don't really work anymore in a lot of situations, and by really understanding the code that you're looking at, you understand the mechanics of the weird machines that are specific to this particular program. So I once found a vulnerability in Flash that I published, and the vulnerability itself was not a very good one. It allowed you to write an integer that you controlled to a location. It allowed you to write an integer to a location that you controlled, but that location had to be 4-byte aligned, so you couldn't do misaligned writes, and also you couldn't control what the integer was. It was it was actually a really low number that you couldn't really control. So people familiar with exploitation will understand that this is not a very good primitive. But I published this paper where I basically said, you can, if you write any low number integer to this table over here that the ActionScript virtual machine uses, you can basically confuse how it interprets ActionScript instructions, and then give it a ActionScript function that basically it'll get confused and then allow you to execute arbitrary code reliably. So people that read that paper thought that this was an amazing leap of logic to find this bug completely unrelated to ActionScript and then applying it over here. But really it was the other way around. I'd reversed a large part of the ActionScript virtual machine as part of the vulnerability research phase. And so I was familiar with it. And when I found this bug over here, I was like, oh, that thing I've already researched is useful for this. And so I think that's a very common strategy, especially, like I said, since a lot of generic exploitation techniques don't work. Being really familiar with the program you're looking at is going to be necessary anyway for doing exploitation. So I guess my maxim is sort of, the more you understand about how a program works, the better equipped you are to find bugs and to exploit them. By the way, the best way to understand how something works is to explain it to someone else, whether you're doing a presentation, a blog post, a book, or training session or whatever. It is amazing how many times I've written papers for things that I basically thought I knew back to front, and how many blind spots I realized I had writing the paper going, oh my God, this thing that I totally thought I understand. Because when you're actually writing it, you're basically, when you understand it for yourself, you sort of take mental shortcuts that you don't really notice that you're taking. And when you're forced to write it down or explain it to someone else, they'll ask you questions where you realize you have no idea and that there's totally a blind spot in there. I actually found a remote sendmail vulnerability this way some years ago. When I was writing out of software security assessment, I was writing the chapter on signal handling, which is pretty straightforward. It's got an API which has some nuances that were different in Linux to BSD. But basically, I knew it all pretty well. But the process of writing that chapter, I started to think about interesting bugs that could occur from signal handling vulnerabilities. And the more I thought about it, I'd recently read, I was pretty familiar at the time with both OpenSSH and SendMail. And I knew they both used signal handling, and so I wanted to see if any of my ideas applied to those code bases. And so I looked at OpenSSH first, and I did find a bug in that. It was less interesting though, you could trigger a crash, but it was basically unexploitable. And furthermore, it was in Kerberos, which was off by default at the time and not really used. Although it was pretty cool being able to tell my friend, hey, I found this new bug in OpenSSH, and he goes, okay, which function? And I go, main. So that was kind of cool. But then I switched over to looking at SendMail, which I'd looked at many times before, but I guess never really paid super close attention to the signal handling mechanics there. And I realized that one of my ideas there totally would work, and was able to construct a reliable remote exploit as a result of basically writing a chapter on something that I thought I knew very well. There's a lot to talk about in what you're really looking for when you're doing vulnerability research. I actually had this whole bit about how to practice becoming good at code reading because it's quite a distinct skill from writing code. And I think there's a lot involved in reading diverse code bases. Even senior developers, I think, are not, quite a lot of them are not as good at reading other people's code as you might expect. But I had to kind of cut it all out, and I will follow up with it. But essentially what I'm looking for really is available attack surface and complexity. Either of these are the bug hunter's best friend. One thing I kind of wanted to mention about attack surface, obviously the bigger attack surface the better, one thing that I like to keep in mind after I've looked at the most obvious attack surface is that quite a lot of the attack surface can be a little bit indirect. So returning to the browser example we had before, looking at something like array.concat might be a direct part of the attack surface, but then looking at JIT generation, like a lot of the modern bugs, is kind of an indirect attack surface. It's like a second order attack surface, you might say. One interesting thing is even mitigations are an attack surface. Obviously mitigations are put there to prevent exploitation, but they're introducing complexity and hence attack surface. And there's been a couple of pretty good ones. There was a mitigation that Adobe put into Flash a few years ago because there was a lot of Flash vulnerabilities coming out at the time. And they changed their heap implementation to basically do delayed freeze. And the idea was to make heap grooming more difficult, so exploiting Flash would be more difficult. But in doing so, they actually introduced a vulnerability in their heap management algorithm that led to direct memory corruption. So basically their mitigation was worse than the thing that they were trying to mitigate against. Your initial perception of the attack surface can sometimes be naive before you start looking at a piece of software. The best thing that I like is when you find a hidden or non-obvious attack surface. Usually this is in the form of like a vendor value-added feature that they've added for themselves to use to make their devices interact nicer or something like that. Microsoft used to be the kings of this, and you come across an attack surface that they've never mentioned and no one's ever mentioned before. And I remember thinking some of those times like, this attack surface is a vulnerability, like a bug is just a detail, there's definitely some in here. And you'll sort of see evidence of this sometimes when someone discovers a new attack surface and then there's like 100 bugs that come out in succession over the next 2 months by when they release the first bug and everyone else looks at it. Complexity is also really good, and it is plentiful. Firstly, the things that programs are actually trying to achieve is really complex at every layer, from the CPU down to the up to the application layer. But in addition to that, a lot of complexity is a little bit unnecessary, but adds to the attack surface for the bug hunter. Firstly, obviously feature-driven, adding new features all the time is often very quickly put together to, sort of define themselves as a superior product to their competitors. When I used to do browsers for a couple of years, whenever I started thinking that I wasn't going to find any more vulnerabilities, I was very excited that W3C had decided to just put in a whole bunch of random new features. So they always kept the attack surface kind of fresh. Legacy support, obviously, is another really great one, usually in the style of downgrade attacks and things like that, but backwards compatibility is always adds a lot of unnecessary complexity. And then lastly, avoidable complexity. Thomas Dooley and Halvar a couple of years ago did this really good keynote that I urge you to go and read called The Anomaly of Cheap Complexity. And he was talking largely about hardware devices really, but everything he says applies equally to software. And the thrust of his talk was sort of that when people are engineering solutions for something, it is cheaper and more efficient for them to make something more complex than more simple, because instead of reinventing the wheel and like writing all the code from the ground up and doing the minimum set of services that they want, it's much cheaper to just get libraries and operating systems or whatever that already exist and sort of string them together so that you don't have to do all of the work yourself. The trade-off of that, though, is that a lot of these libraries and so forth are way more complicated than what you actually need it for because they're general purpose. And so you end up pulling in the thing that you want to use, but also a whole bunch of other stuff that you may not have intended for your program to utilize. And sometimes it's difficult to disable those features or impossible, and sometimes you don't even know about them. So we all saw this like log4j vulnerability that came out, which is kind of a good example of this. Essentially everyone using the same library, which was a little bit of an overpowered component for what it was supposed to achieve. Basically it just logs error messages, right? But it had this bonus formatting functionality that, among other things, kind of allowed you to download and run arbitrary code. Now, this is it was part of to do custom formatting of error messages, but this is a feature that probably quite a lot of the consumers of this library didn't really need, especially pulling down pulling down code remotely, and probably quite a lot of the consumers weren't even aware of its existence. They just pulled it in because they're like, oh, someone's already written a logging subsystem, why should I do that? And so these kind of bugs are really interesting. Borrowing ideas is another fun one. I sort of talked about before how diffs are really useful for seeing what vulnerabilities look like in the context of a particular code base. But also just the bug trackers in general, they're really interesting to see what kind of bugs have been present in the code base before. Some of them security bugs, but some of them just crazy bugs that they've run into during the lifespan of this program in their operation. And some of those things they don't recognize had security consequences, or perhaps didn't have security consequences at the time, but now you're like, oh, that idea, actually, if I can replicate that now, that might be problematic. So it's good for inspiring new ideas, variants in other code bases. And you can also, when you have these new patterns, you can sort of think about, perhaps how to automate them as well. More than one person has also told me, and this is totally mean, but I guess it's viable, is they track commits by specific developers that they think make security security consequential mistakes often, and they track all their commits and go and look at all their code, which is kind of rude, but I guess it works. Comments in the code also, comments in the code base itself is also pretty useful because, again, they document things that you might never have thought of. I've found bugs in one or two applications before because I've looked at comments and they've sort of said, they've sort of talked about a complex bit and why they did it. And then I'm like, oh, well, I wonder how the other guys got around this, and they hadn't, essentially. So document your findings. Developers and I think vulnerability researchers are pretty poor at documenting in general. But when I talked about the stuff related to failure, one of the things I said was, you're going to want to come back to these code bases later, and for you to do that effectively, you kind of have to take notes about the bug candidates you had, the idiosyncrasies you had, data structures and algorithms, and it's really important to document failed ideas. It's as important as documenting all the other stuff. I have wasted quite a lot of time in my life by going back to a code base and seeing something, and I'm like, that looks like a vulnerability, and not far into it I realized that I've looked at this exact thing before and decided it wasn't a bug, but I never wrote down why. So usually what I think is, I was on crack last time, this is totally a bug. And I do the exact same process of spending hours chasing it down before getting to the endpoint and realizing why it wasn't a bug, and then remembering like, oh yeah, I discovered this last time. So writing down the ideas that failed and why they failed is really useful. So when you go back, you can just check whether that particular condition has changed or not. And so this is all with the idea of having a long-term view. Like I have notes on code bases that span a decade of that code base. And so if you're spending any significant amount of time, looking at a particular code base, these notes will become invaluable. I sort of talked about this before. In fact, I told you guys this already on Twitter, but I'm not the first person to say this. If you spent the amount of time putting in the work to understand how a particular technology works and a code base works, one of the best ways to maximize that is to look at everyone else who is implementing the same thing and seeing if they make the same mistakes, because very frequently they do. Even if they don't make the same mistakes, someone here might carefully avoid a mistake, but because they're going to so much work to avoid it, it gives you the idea that that's a particularly difficult thing to avoid, and you go and look at how the competition did it. So whenever I'm looking at some complex component and I sort of understand it, I find it really interesting to look at different implementations from my original target to see if they've made different mistakes. And incidentally, when I'm having difficulty understanding what a particular component is doing, sometimes I go and look at a different code base where perhaps their code is laid out in a way that I can understand more readily. So it's useful for that as well. The example I gave before about Natalie's signal bug was actually on a blog post that she did that you can go and read about, which is a really good example of this. She invested the time. She, her startup cost was understanding all of this web RTC and the state machines and everything like that. She'd invested all this time learning about that, and so naturally had gone and looked at all of the other, like, okay, there's a bug in Signal, how do all these other things do it? And in that blog post, she points out vulnerabilities in quite a few other, messenger programs, many of them quite similar in nature, because she'd already paid the startup cost, and so to maximize her return, go and look at everyone else that did it and see if they make the same mistakes. Revisiting code bases is another thing that I've sort of talked about before. Code bases are not static. Code gets rewritten, features are added and changed, and also the environment is not static. The state of mitigations and stuff like that changes. I've had, and I'm not just talking about re-looking at the code bases to find new vulnerabilities, but even to look at failed bugs. So when I was talking about documentation and recording failed vulnerabilities, I had an example not too long ago where I found a vulnerability that was like an overflow in a data structure, and the fields that I could overwrite were not useful at all. They basically weren't used ever again. I also couldn't overflow far enough to overflow into adjacent memory to do something useful there. So essentially the bug was pretty useless. But I went back to that same code base a year later, and they'd added some new features that were completely unrelated to the stuff that I'd found a bug in. But the consequence of them adding those new features were they'd added a couple of more members to that data structure that I could overflow into. And so this bug that was useless before suddenly became useful because I was able to use these new fields to do something that had security consequences. I also had one other vulnerability several years before that where I was really excited when I found it, and when I went to trigger it, there was a null dereference that triggered on the same code path to where the interesting vulnerability was, and there was no way around it. And so that was, obviously frustrating, but again, I went back and looked at that code base later, and they'd fixed the null dereference, but not the other vulnerability. And so having an idea of what bugs you have that failed, and then checking whether those conditions are still true in newer versions of the code base can be really useful. Environment the same. Usually adding mitigations and heap hardening and stuff has the effect of making bugs unexploitable. But that's not always the case. Again, there was one vulnerability I found where I could exploit it, but not very nicely, because it was very hard to do a particular heap groom, and essentially when you got it wrong, you corrupted some metadata on the heap and it would crash immediately. And then later on, they rewrote their heap implementation to remove encoded metadata from the heap and have it out of band. And it made the exploit dramatically more reliable because, if I got the heap groom wrong, I could just try again and there was no consequences. And so even though things generally get more secure and harder to exploit, that's not always the case. This is one of the most key points that I want to make, apart from really understanding the code you're looking at, is to analyze your failures. Vulnerability research, you're constantly dealing with incomplete information, which is what makes it so hard to stay motivated. You can look at a code base and go, did I do everything right and there was nothing here to find? Or is there things that I'm just continually missing? And it's not very often where you get a chance to have that question answered for you. So of course it's very frustrating when you spend a bunch of time looking at a code base, don't find anything, eventually abandon it and move on. And then like 3 months later, someone finds this amazing exploit in exactly the thing you were looking at. But you can actually use this as a learning opportunity, and it's a fairly unusual one. You can go back and look and see, it's very much worth your time to go back and look and see what is the bug they found, and why did I miss it? A lot of the times when this has happened to me, it's just been like, they added this new feature that wasn't there when I looked at it, or I never looked at that code because it was non-default and no one used it, and now it is default, which sort of speaks to my previous point about revisiting code bases. But sometimes they find vulnerabilities that you never would have found because it just wasn't, it wasn't in your, I guess, in your mind to look for some of those things. Or they found a vulnerability that you found a few of the idiosyncrasies, but you never quite put them together in the way that that person did to discover that it had security consequences. So basically, you can go back and see why you missed it. If it's something that you totally weren't aware of at all, then you sort of realize that you have a blind spot in your vulnerability research, and you can go and learn about the concepts that person used to find that vulnerability, and sort of add to your mental arsenal of things when you're doing vulnerability research. And then if you found a few of the idiosyncrasies but didn't put them together, again, this can suggest to you that you're on the right track. You're finding the right kind of elements that make up vulnerabilities, but perhaps you need to work harder on like brainstorming, putting those things together before you abandon it and move on. The last thing I sort of want to talk about is tooling. I sort of mentioned this before. Tooling, and mainly I'm talking about fuzzing and static analysis stuff here. These can save a lot of time and energy, and it is worth your time to go and see what's out there. Usually for some of these tools to be effective, they won't be off the shelf perhaps as effective for some of the larger targets. You'll have to take it and add your own understanding that you've gained from the context of this to find specific patterns that perhaps you're aware of to get more results. But definitely tooling and interactive testing can save you a lot of time and energy, and it's been a big mistake throughout my career that I never really do this because I'm super lazy. But also actually, like I said before, a lot of the times when I'm looking at code, I'm actually curious about the technology rather than just finding bugs. So, in that respect, getting existing tools and running them is not useful, although admittedly building the tools is. But anyway, if you're someone who doesn't like doing fuzzing, that's fine, but you should probably team up with someone who does, because they're going to be able to save you a heap of time. Like, fuzzing now is a very big and complicated field. Back when back when it was in its infancy, it was dumb fuzzing essentially, but now it's a very complex field and actually requires you to know quite a lot to be current. So if you're not someone who's interested in doing that, you should team up with someone who is. Early in my career, I was very skeptical of both static analysis and fuzzing. Static analysis I basically thought was too academic to be particularly useful, and fuzzing, again, I said it was in its infancy, but it's also very obvious that given time, the sophistication would improve, and more importantly, when people were able to deploy it at real scale and at Google scale, it's very obvious that it's going to find a whole heap of stuff. Richard Johnson, who gave a training at OffensiveCon about fuzzing, said this just a few months ago: world-class bug hunters always begrudgingly accept the power of fuzzing. It's inevitable. That sounds very Borg-like, but he's actually right. It's a really useful addition to your vulnerability research. One thing I would say about tooling, though, is especially for young people that are getting into vulnerability research for the first time, is that it can be a huge rabbit hole that diverts you from ever really gaining the skills you need to really understand code and be able to read other people's code and understand context. Because basically tooling is writing code rather than reading, which most people are more comfortable with. It's dealing with less ambiguity. You get to solve engineering challenges. You will learn an awful lot, especially if you're making very specific fuzzes and stuff, because as part of building that, you will be doing the reading to understand the context of what you're trying to achieve. But yeah, essentially, if you're someone who does tooling and becomes more interested in that side of things, I guess I would suggest the inverse of what I said on the previous slide, which is you should probably consider teaming up with someone who's very focused on vulnerability research and getting results, because I've seen a lot of times in my career, people start doing vulnerability research and they're like, I'm going to just automate this thing. And then they spend forever doing that and they forget why they were even doing it. And they make this huge complex program that might not even be particularly useful in real life, because the things that they think are elegant and are going to work in their mind don't actually have practice. So by teaming up with someone who's very focused on just finding bugs, you're getting continuous feedback of, I know you think this is cool, but this doesn't work at all. This less elegant idea actually works fantastic. You should do this. Yeah, I just kind of had that quote that I sort of talked about before. Halvar often quotes me saying this, so I'm quoting him quoting me. It's amazing how much work people will do to not understand something, and that was sort of talking to that thing where, especially early in my career, people would put so much work, years into, months and perhaps years into building these epic tools, and I'm like, you could have just read the code and found all these bugs. So there's kind of a trade-off there. So that's basically all the rules I could fit in. I guess my takeaway is that vulnerability research is difficult, but it's a learnable skill. That's my cat, by the way. I think that obviously I've only had time to do a very brief overview of some of this is by no means comprehensive, but I'm thinking of expanding more on the things that I had to cut out, because I think it is a teachable skill, and teaching that skill involves more than just pointing out what code, this code has bugs in it, this code has bugs in it, but understanding the temperament that you need, understanding how to manage your projects, and understanding complex structure from reading code. And so I think especially dealing with frustration and stuff is a key differentiator to success, and people that manage to master that will be much more successful in vulnerability research and less likely to burn out early. And lastly, I guess I wanted to say reading is a skill distinct from writing code, and it takes a lot of practice, and most people that write code think that they're automatically good at reading other people's code, and that's not really the case. So you actually have to commit effort to becoming good at reading code and learning about what to look for that have potential security consequences. I guess finally, anyone who knows Runa Sandvik, it's her birthday today, so say happy birthday to her on Twitter if you're friends with her. And that's all.